Now that we have talked about substitution and elimination in order to solve linear equations, we can also bring up a concept called the matrix. So what is a matrix? A matrix is just simply a rectangular array of numbers. So in this particular array, we have m rows and we have n columns. So columns go up and down, rows go side to side, and rows are usually mentioned before columns. So this is the element a sub ij, and this would mean that it was in the ith row in the jth column. So this element in our rectangular array, in our matrix, is in the second row, third column. So what we can do is we can take a system of equations that's linear and rewrite it in terms of a matrix. So we can talk about a coefficient matrix, and a coefficient matrix, notice if we have our system as x's and y's, and then our right-hand side, if we pluck the coefficients 3, 5, 2, negative 7, and form a matrix out of those, this is called the coefficient matrix. What we can also do is we can add to this matrix the right-hand side, 60 and 42, and that's called an augmented matrix. Augment just means to add on to. So we've added onto our matrix another column. And we usually separate the coefficients from the right-hand side with a vertical bar. So we want to take this system and rewrite it as an augmented matrix. So you'll notice that there are two equations. So we will have two rows, and the coefficients are 2, 10, 3, and 15. And then we will separate the left-hand side from the right-hand side with a vertical bar, and here is our augmented matrix. Let's look at example 2. Here we have 3 equations, so we will have 3 rows. And so our coefficients, well, notice that x would have a coefficient of 1, so we would have 1, 2, negative 3, 3, this is like a negative 1, and here's a 1. Notice there are no variables in our matrix, just the numbers, just the coefficients. Vertical bar, and then we will write our right-hand side. Negative 17, positive 16, positive 23.